40 divided by 18, when you divide that out, you get 2.22 repeating. So 1.42 and 2.2 aren't the same thing, so therefore these are not similar. Not similar. Because they don't have a consistent scale factor. Number 21, I'm going to do the same thing. Take corresponding parts. 36 over 24. And 32 over 24. I don't even need to solve anything. I know 36 over 24 is not the same as 32 over 4, so these are not similar as well.
Can you determine if they're similar without setting them up like that?
I don't think so. I mean, by looking at it, 36 over 24 doesn't equal 32. It depends. Sometimes it's obvious, but sometimes it's not. Okay, 22, determine whether the triangles are similar. If so, write the similarity statement and name the postular or theorem you used. Okay, so this corresponds with this side here. So I'll do 30 over 20. This corresponds with this, 12 over 8. And then this one corresponds with this one, 36 over 24. 30 divided by 20 would be 1.5. 12 divided by 8 is 1.5. And 36 divided by 24, if you were to do it in a calculator, is also 1.5. So it does have a consistent scale factor, so they are similar. The reason is side, side, side similarity. (23), this is one that some people missed on the homework actually. Vertical angles are congruent, so we have one angle we know is the same. Then they also show that this is parallel to this, meaning that these are transversals. So with transversals, alternate interior angles are congruent. So this angle is then congruent to this one. And you can also say that this angle is congruent to this one here. So you have at least two angles that match. So you have angle-angle similarity. And then 24, it's just showing angle measures. If all those angles match, then they are similar. So what I'm going to do is find out this third angle. So 180 minus 76 minus 48 gives me this angle here, 56 degrees. If two of the angles match to this, then they're similar. However, I have 76 that matches and nothing else. So these are not similar. (25). These are pretty easy. Maybe I'll skip over these. Here, I'll put down the answers for these, and then you can go ahead and solve them on your own. So x equals 7.5. 26 I crossed out just because the numbers are so big it's annoying. This one solves to x equals 8.8. 28, y equals 7.5. This one's x equals 8. For this one, you'll have to set up the two separate triangles. And then this one is x equals 15. So those, I'm just putting the answers so you can go through and do the work for them, but it's setting up a proportion, which you guys are pretty good at. 31, the perimeter of DEF is 90 degrees, so perimeter here is 90 centimeters. These two triangles are similar because it tells me so. Find the value of x and y. Okay, the perimeter of this one, if you add up those three numbers, is 60. And the perimeter is in the same proportion as the side length. So if this corresponds with this, then 26 over x would equal 60 over 90. And you can solve it like that. 60, and x equals 39. It also asks us to find the value of y. So same thing for y, I'll do 10 over y equals 60 over 90. And y equals 15. Okay, on the next page, I'll fill in the answers to the proportion ones. So just when you get time, either throughout the day or later on this afternoon, just go through, do the work, make sure that you're getting the correct answer. And then 38, state whether the dilation of A to B is an enlargement or reduction, then find the scale factor of the dilation. So specifically A to B, A here in the first example is smaller than B. It's getting larger, so it is an enlargement. And then it wants to know the scale factor. So you do the second over the first, so B over A. Just choosing a side. B is 6 over this length here on the corresponding part of A is 4 units, 6/4, simplifies to 3/2. So K equals 3/2, which makes sense because if it's an enlargement, K has to be greater than 1. And then B, A to B, B is smaller, so it's a reduction. Do the second one over the first, so it's still going to be B over A. Choose a corresponding side. B is 4, and A is 1, 2, 3, 4, 5, 6, 7, 8. That simplifies to 1/2, so K equals 1/2. Then these last two here, the distance between Boston and Chicago on a map is 9 inches. If the scale of the map is 1 inch to 95 miles, what is the actual distance from Boston to Chicago? So the scale on the map is 1 inch to 95 miles. Set that up as a ratio and put that equal to the 9 inches on the map. And we're going to figure out how many miles that is. So 1 times x is just 1x equals 95 times 9 is 855 miles. Divide by 1 on both sides, and you just get x equals 855 miles. That's how far apart approximately Boston and Chicago are.
Can you scoot up?
Yes.
Talk through questions again?
Oh, I will in a second. Let me just finish this here. So number 40, the last question. A miniature replica of a fighter jet is 4 inches long. The actual length of the jet is 12.8 yards. What is the scale of the model? So model always goes on top, so 4 inches over 12.8 yards. With the scale of the model, it doesn't have to be in the same unit yet. To simplify this, I'm going to take this down to 1 inch. There's no good way to simplify it other than that. So I'm going to take this down to 1 inch by dividing by 4. And whatever I do to the top, I do to the bottom. 4 divided by 4 is 1 inch. And 12.8 divided by 4 is 3.2 yards. That's the scale of the model. So for every 1 inch of the model represents 3.2 yards of the actual thing. Then it says how many times as long as the model is the actual jet. To get this, you need to put it in the same unit. So I'm going to change this into inches by multiplying. So in a yard, there's 3 feet, 36 inches. So I'm going to multiply this by 36 inches. 3.2 times 36 is 115.2. So we get 1 over 115.2. So for every 1 inch of the model, there's 115.2 inches of the jet. So that means that the jet is 115.2 times bigger than the model. And that's it. Okay, so now I'll move it up so that way you can get the answers from the top if you need it.